Now let's take a look at ionic versus covalent bonding, knowing what we know about this covalent and polar covalent and how does this all fit together. So if we take an ionic compound, let's say cesium chloride, and we look at the electronegativity of both the cesium and the chloride. Cesium has an electronegativity of 0.8 and chlorine has an electronegativity of 3.0. So our change in electronegativity, or the electronegativity difference, is going to be 2.2. Now if we take something like Cl2, we look at the electronegativity difference between each of these atoms. Chlorine has an electronegativity value of 3.0. And it's bound to a chlorine, so it's going to have the same electronegativity. So the electronegativity difference is going to be 0. Okay? So if our electronegativity difference is 0, this is what we'll call our nonpolar covalent. If we look at a polar covalent complex, like HCl, our hydrogen has an electronegativity of about 2.1, our chlorine 3.0. So our difference in electronegativity is going to be 0.9. We have a nonmetal bound to a nonmetal here, so this would be characterized as polar covalent. So we can kind of set up a continuum between our ionic and nonpolar covalent bonds. So on the left-hand side, we'll say our bonds are ionic. On the right-hand side, they're covalent. And here we can say ionic. In the middle, we'll say is polar covalent. And on the right, we have our nonpolar covalent. And this is more of a continuum rather than an exact cutoff between what an ionic bond and a covalent bond is. You can have ionic bonds that have a small electronegativity difference, and you can have polar covalent bonds that have a fairly large electronegativity difference. So when we look at each of these bonds, it's more of a continuum and a spectrum, and it's hard to say what the exact cutoff is between an ionic and a covalent bond. Our most important is our nonpolar covalent down here, because our electronegativity difference here is going to be 0. Okay? And we can look at the various properties of the strengths of the electronegativity difference between the ionic and the polar covalent compounds, and we'll do that in a later chapter. So in the next video, we're going to look at something called a dipole moment, which looks at the differences in the electronegativity to characterize our polar covalent bonds.